Okay, so the first two problems here discuss writing a fraction to represent shaded portions, okay? And these are basically just concrete models for fractions. So this first one here, we have the square divided up into 4 equal parts, so that's my denominator. And then we want to know how many out of that 4 equal parts are shaded. Well, of course, that would be 3, so that would be my numerator. So 3/4 of this fraction is shaded. Okay, same process for the circle. First of all, we see that the circle is divided up into 6 equal parts, so that's my denominator. And then 5 of those have been shaded, so 5 is my numerator. So 5/6 of this circle is shaded. Okay, so let's go to number 3 and write the fraction in simplest form. And so we start with something pretty simple, which is 6/8. Okay. And so for 6/8, we know that we need to divide the numerator and the denominator by the greatest common factor for 6 and 8. Now this is pretty easy to look at and tell that the GCF for 6 and 8 is 2. In other words, the largest thing that'll divide evenly into both 6 and 8 is 2. And so 6 divided by 2 gives us 3, 8 divided by 2 gives us 4, so number 3 reduces to 3/4. Okay? Number 4 is 50/98. And so we can look at that, and again, if you're not quite sure what your GCF is here, you could do your prime factorization and find your GCF like we did in chapter 4. But another thing I notice here is that they're both even numbers, so I can always start with 2, and then if necessary, keep dividing it down until I get it in simplest form. But let's start with 2. Let's divide the numerator and the denominator by 2. 50 divided by 2 gives me 25. 98 divided by 2 gives me 49. And I know that I can stop here because this is simplest form. So let's talk a minute about how we know for sure when a fraction is in simplest form. A fraction is in simplest form when the only thing that your numerator and your denominator share in common as far as common factors is 1, okay? Or remember, that means that the numerator and the denominator are relatively prime, we would call it, because the only factor they share in common would be 1. That's how I know for sure a fraction is in simplest form. So for number 4, it would reduce to 25/49. Okay, so for number 5, we have a negative fraction. We have negative 70/88. So negative 70/88, and my GCF, I could find by doing prime factorization if I needed to, and like we did in chapter 4. But I notice that these again are both even numbers, so I'm going to start with 2 and see if possibly this is my GCF or if I'm going to need to keep reducing. Okay, so this is a negative number. Negative 70 divided by 2 would give me negative 35, and 88 divided by 2 would give me 44. Well, I know that the only thing that this negative 35 and 44 are going to share in common would be 1. And so I know this is simplest form. Now, let's talk about another way this answer could be written. This could also be written with the negative sign in front of the entire fraction. And 35 divided by negative 4 is equivalent to these two, but this is not considered simplest form. And I'm mentioning that because if you type this in MyLabs Plus like this with the negative on your denominator, that's not going to be considered simplest form, and so they'll tell you that that's not the correct form the answer has to be in. So you would want to give this answer simplest form either this way or this way to get the full credit. Okay, so for number 6, we have 18xy squared divided by 45x squared y. And so we start with what I call the number part first. And so I know that the GCF for 18 and 45 is going to be 9, okay? And so now if you didn't know that the GCF by looking at that was 9, you could do your factor trees and your prime factorization. But I know 9 goes into 18 2 times, and I know 9 goes into 45 5 times, okay? And so I'm going to now go to my variables. And these, I have x to the first divided by x squared. A fraction bar really means division. And so remember, when we're dividing with the same base, we subtract the exponents. So that's the rule I'm going to use here to reduce my x's. And I'm going to say 2 minus 1 gives me x to the first, since 2 minus 1 is 1. And then I have to decide, once I've reduced these, whether I put that x to the first on the top or the bottom. And I'll put it on the bottom because that's where I had the higher power. Now I need to do the same thing with my y's and reduce those. So again, that's really y to the first here. I subtract my exponents. 2 minus 1 is going to give me y to the first when I reduce these. And so where will that go? Well, this time y to the first is going to go on the top because that's where I originally had the higher power. So I'll have 2y divided by 5x, or 2y over 5x as my final simplified answer there. Okay, so for number 7, there is nothing I can do to this. This is already considered simplest form. And I wanted to put this one on here because sometimes I'll have students that think that you can do V and V here and R. You cannot do that. In order to reduce something as far as like a V over V or R over R, I would have had, that V would have had to have been a factor of all of these terms, top and bottom, and been able to have been factored out. Okay, and I would have been able, had to have been able to have factored out a V on the top and a V on the bottom for that to reduce, and the same thing for the R's. So this one is already in simplest form. So there is nothing else that you can do to that, okay? So cannot simplify that anymore on number 7. Okay, so we have on this next part, find the requested fraction. And this deals with equivalent fractions. Okay. Now, if we go back up to number 3, 6/8 we said simplified to 3/4. So there's an example of equivalent fractions right there. Okay, so if we kind of just come to the side from our sheet a minute and let's talk about what makes two fractions equivalent. So a good example we've already looked at is 6/8 equals 3/4. Okay, and these, because 6/8 reduces to 3/4, we know these are equivalent. Another way that you can check to see if fractions are equivalent is by their cross products, okay? So for 6/8 to be equal to 3/4, their cross products have to be equal. Well, let's test that out. 4 times 6 is 24. 8 times 3 is also 24. And because their cross products are equal, then I would also could say that these two fractions are equivalent, okay? So back to our problem on number 8, we have negative 9/16 equals something over or divided by 96. And we're trying to find the missing numerator here, okay? So, a couple of ways you can think about this, but the way that I've always was taught to do this is I say 16 goes into 96 how many times? And if you divide 16 into 96, it'll go 6 times. So I multiplied that 6 times negative 9, and that gives me negative 54 for my missing number. Okay, but now let's think about why that works. For these two to be equivalent, that means that I had to multiply the top and the bottom of this fraction by the same number in order to get this equivalent fraction. So when I am working this and I'm saying 6 goes into 96 6 times, I'm really just trying to figure out here, okay, 16 times what gave me 96? Well, that would be 6. And so if I multiplied the bottom or the denominator by 6, then I had to multiply the top by 6 as well. So either way you think about it, but 16 goes into 96 6 times. 6 times -9 gives me -54 is the way most people are taught to find these missing numbers in a fraction. So number 8, the missing number was -54, so that would be -54 over 96. Okay, so for number 9, we have 14/3 equals something divided by 6. Okay, so 3 goes into 6 2 times. 2 times 14 gives me 28. Because 3 times 2 is 6, then I had to multiply the top number by 2 as well. So that gives me 28/6 for number 9. Okay, so number 10, I think we've already answered. We know that 6/8, if we reduce it, reduces to 3/4. So we know that the only equivalent fraction here would be 3/4. Now I could test the rest of these out, and I could use my cross products, because if I do 9/16 equals to 6/8, that would not work because my cross products would not be equal. But this one we've already talked about, so we know the answer is B, 3/4. Okay? Now, if you use that method on number 11 that I just talked about, I want to know if these two fractions are equal. And so I'm just going to cross multiply, and if my cross products are equal, then these two fractions are equal. That's how I'm going to work these. 135 times 1, of course, is 135, and 9 times 15 is also 135. So since these cross products are equal, the fractions are equal. So the answer would be yes there. Okay, I'm going to use the same method here, and I'm going to multiply -4 times -18. So if I set up my problem, and I'm trying to decide if these are equal or not, I'm going to cross multiply. So -4 times -18 would be positive 72. And 36 times 2 would also be positive 72. So if my cross products are equal, then my two fractions are equal. So the answer would be yes here as well. Okay, so it says give your answer the question and give it your answer in simplest form, so don't forget that. So Julia preheated her oven for 8 minutes. What fraction of an hour was this? And they even tell you that an hour has 60 minutes. So 8 out of 60 minutes, and we need to reduce that. Okay, and I know that 4 will go into both of these. So 4 goes into 8 2 times, 4 goes into 60 15 times. So that would be 2/15 of an hour. Okay. All right, this one's pretty straightforward. Since there are 7 days in a week, how many days are in 4/7 of a week? Well, you know, we could work this out as 4/7 of 7. And so 4/7 of 7, or 4/7 times 7, is of course going to be 4. But I think we can just really pretty much look at that and answer that that's going to be 4 days. Okay, this one, it says a teacher bought a package of 48 markers for her first grade class. After one school year, 5 markers were still working. What fraction of the package of markers was working? Express the result using a simple, and then they use this word convenient fraction that is close in value to the exact answer. Well, we know the exact answer is 5 out of 48 were still working. But they want what they're calling a more convenient fraction. In other words, a nicer fraction than 5/48. Well, to give a more convenient fraction here, I could say that 48 markers was about 50, okay? And so 5/50ths reduces to 1/10. So we could say approximately 1/10 of her markers were still working at the end of the year. And that's what they mean by convenient. In other words, 5/48 is not a really common fraction. 1/10 would be a little bit nicer or more common way to express that. And so that's really not an exact answer, that's an approximation there. Okay, so this says arrange the fractions in ascending order, and that means from least to greatest, okay? And so if we look at number 16, and we want to arrange the fractions in order from least to greatest, then we need to write these as with the same denominator. Okay, so to find a least common denominator, that's the same thing as finding a least common multiple. And when I'm finding a least common denominator between 4 and 16, I always point out to students that it has to be at least as big as your biggest number or bigger. What do I mean? Well, I start with 16 and I go up from there if necessary. A lot of times students, when you ask them a question like least common denominator between 4 and 16, they'll give you 4. Well, that cannot be a least common denominator. Your least common denominator has to be at least as big as your biggest number or even bigger. So I start with 16, and will 16 work? Will 4 go into 16 evenly? Yes, it will. So 16 is my least common denominator. So now how do I find my equivalent fractions? Well, we just practiced that back on, I believe it was 8 and 9, and so we're doing that same process. So if we want to write it the way it looked on 8 and 9, we could set it up like this. And so 4 goes into 16 4 times. 4 times 1 gives me 4. And of course this is just going to stay 3 16ths. Okay, so if I do ascending, which is least to greatest, we know now we compare the top numbers, the numerators, once we have them with the same denominator. So we know that 3 16ths is smaller than 4 16ths, but we need to put the original fraction given. So this one would be smaller. This one would be the larger one. Okay, so we would write our answer as 3 16ths, comma, 1 4, which on this sheet is C. Alright, 17, same type question. We want to arrange in order from least to greatest, 5 36 and 10 12s. So we need to find a least common denominator between 12 and 36. So we have to start at 36 at least. Well, will 12 go into 36? It will, so I'm going to use 36. So let's just keep these the way they are. 36, of course, goes into 36 one time. 1 times 5 is 5. Of course, this is going to stay 5 36. Okay, let's get the equivalent fraction here. 12 goes into 36 3 times. 3 times 10 is 30. Well, least to greatest, of course, 5 is less than 30. So that means if we go back to our original numbers, 5 36 is less than 10 12. And so that would be ascending order. Okay. And so we'll just put that in the blank. Okay. On this, it says choose the pair of rational numbers that are between the given fractions. And there's a theorem in your textbook in chapter 6 that says that there is infinitely many rational numbers in between any two given rational numbers, or in between any two basically given fractions. And so on 18 we're just asked to find one, and it's a multiple choice question. So since they've already given us choices for our answer, and if you're looking at that and you're thinking, well, how can I find something in between 2/5 and 3/5? Well, we've got to find a bigger denominator to use in order to be able to find at least a fraction in between these. So if you kind of go ahead and look at your multiple choice answer, you can see that the denominators on all these choices is 15. So obviously they're wanting us to change these to equivalent fractions using the denominator 15. And so if I change my denominator to 15, and to do that, I can say 2/5 equals something over 15 and then I can also say 3/5 equals something over 15. And remember to do that, I say 5 goes into 15 3 times. 3 times 2 gives me 6. And then 5 goes into 15 3 times. 3 times 3 is 9. So basically, I need at least a fraction in between 6/15 and 9/15, because 6/15 is really 2/5 and 9/15 is really 3/5, but now I'm able to find a fraction in between these. So I have a couple of choices here, Donna. We could do 6, 7, 8, so we could do 7/15 here. I made that fraction more a little too large. Or we could do 8/15 here, okay? So now, and it actually said a pair, so I thought it just said one, but actually a pair. And so that would be my pair of rational numbers in between 2/5 and 3/5. It would have to be 7/15 and 8/15, which is answer choice B.